So when I'm looking at balancing combustion reactions, I kind of keep in the back of my head, it's okay to have numbers that can get a little odd or weird or large. So if you had a 17 in there or a 22 or a 12 or those kinds of numbers, they aren't that unusual for combustions. Now, if you had those kinds of numbers for a single and double displacement, you want to double and triple check yourself because usually, it's like 2s, 3s, and 4s. You don't have huge numbers like 25 or 27 or something. But these combustions, they can sometimes have larger numbers, so that's okay. The other thing is they can make you feel a little crazy going back and forth, like you aren't, like if you get off in one section of it, sometimes it can just feel like it's really hard to finish balancing. So I always tell people, balance oxygen last, this oxygen, balance that one last, because it kind of fixes it. Also, sometimes you'll see this as a fraction, so I'll show how that can look as a fraction. And then the other thing is that if you balance back and forth and you just feel like you're going in circles, when you throw a 2 in front of this hydrocarbon, sometimes it helps. And by sometimes, I mean when your hydrogen is odd, it almost always helps to throw a 2 in front and then balance the thing, I'm telling you. So that's my little trick when you have an odd number of hydrogen. So let's go ahead and balance these two reactions and see where I end up with them. And also with combustions, it's very easy to end up with like a multiple higher than what you meant. So maybe like 2, 4, 2, 4. And in that case, you've got to simplify it down. So that's another thing that can happen with the combustions. So again, I'm going to balance my carbons and then my hydrogen. So my carbon gets 3. And then my hydrogen, I've got 8. And since I have 2 here, I need that to be a 4. So now I'm going to add it up. I've got 6 oxygen. And then I've got 4 oxygen. So I've got a total of 10 on this side. For me to get some number times 2, I need a number times 2 to give me 10. So that's going to have to be a 5. You see how they're kind of, those are okay numbers, but they're kind of a little bit different than maybe what you expected. And I know that since I have a 1 here, it's in the smallest, lowest ratio, so I'm good to go with that. Now, over on this odd one, I went ahead and threw a 2 in front of the carbon. Let's see if that helps me. So when I balance my carbon, I'm going to need a total of 8. And when I balance my hydrogen, I'm going to need a total of 18. Now, I've already got a 2 here, so I'm going to put a 9 in front. Now, this is 9 oxygen, and then this is 16 oxygen. Now, when I add that together, that's actually going to give me 25. And for me to make that be balance out, I can either use 25 halves. You see how that kind of works? 25 halves is 12.5. If you don't see how that works, the other thing that you can do is you can go ahead and make that 2 a 4 and see if you like that better. But when the hydrogen is odd, just expect it to be a little bit more work. And notice how I'm erasing everything. I'm not leaving anything behind before I mess with it being 4. So I've got it being a 4 there. So now I've got 16 carbons and I've got 36 hydrogens, which is 18 hydrogens. So now when I do it, and I've got 18 oxygens and I've got 32 oxygens, that gives me a total of, looks like 50 oxygens. Whoa, that's a lot. So that would need to be a 25 in front for me to be 50. All right, so, well, what about the whole situation where you'll see these as fractions? You do. This is as written. These are all correct. But you could also see this written as, this top one could be written as 5 halves. And then this is made a 2. And then this is made a 3 halves. And this is not as common to do it when you end up with more than one fraction. Most of the time, they just like the fraction right there. Like for this lower one with these really large coefficients, it's so much more common. You'll see a 2 here. In like textbooks and stuff, you'll divide everything by 2. 25 halves, 18 becomes 9, and then 16 becomes 8. And it kind of lowers the coefficients. Again, this is kind of like a combustion only thing. We don't typically use fractions when we are balancing, but combustions, especially in front of the oxygen, they can show up with fractions. Those are kind of just my little tips on balancing them. Take a deep breath before you balance combustion reactions, and then give it a try.